At 6:42 p.m. Eastern Time on Saturday, November 19th, the United States launched its most scientifically sophisticated geostationary weather satellite to date. Called GOES-R before launch, it's now known as GOES-16 because it's the 16th of its kind to reach orbit. The satellite, which is about the size of a school bus and weighs more than 3 tons, arrived at Kennedy Space Center in late August from Lockheed Martin in Denver, hitching a ride on an Air Force C-5 plane. After months of testing in Florida, the satellite was scheduled for launch on November 4th. But Hurricane Matthew caused problems with the infrastructure at Cape Canaveral and delayed the launch by 15 days. Just yesterday, the satellite got to an altitude of about 22,000 miles above the equator, so it's officially in geostationary orbit. It will now undergo about a year of checkout and validation, and in late 2017, it will replace one of the 2 operational U.S. geostationary weather satellites. 3 more satellites in this series are scheduled for launch in 2018, 2019, and 2024. Now, for viewing the Earth in real time, the new satellite provides 3 times more spectral information than at present. That means 3 times as many wavelengths of energy to use to image the planet. The spatial resolution is 4 times greater, and the satellite can scan half the Earth in 5 minutes, 5 times faster than currently possible, and smaller regions can be scanned every 30 seconds. Combined with a new feature, real-time mapping of total lightning activity, this should provide more lead time for severe weather warnings. Now, the weather monitoring will be done by 2 instruments. The ABI, or Advanced Baseline Imager, is the camera. The geostationary lightning mapper will track lightning strikes. The satellite also has 4 space weather instruments. WxYz and WxYz will point at the sun and measure X-rays and particles from solar outbursts. 2 others will measure the magnetosphere, where those particles interact with Earth's magnetic field. Together, these instruments will improve predictions of communication and navigation disruptions. GOES-16 joins a constellation of other geostationary weather satellites operated by the European Union, Russia, China, India, Japan, and South Korea. Together with an array of polar orbiting satellites, they provide more than 90% of the data fed into numerical weather prediction models, the computer models we depend on so heavily. One last thought. I've heard all kinds of superlatives about this new satellite. Game-changing, revolutionary, like going from black and white to super high-def TV. Now, don't get me wrong. Once the satellite is operational, you will notice crisper satellite images. But don't expect weather forecasts to improve overnight. That's always been a gradual, baby steps process, and one satellite won't change that. We'll have your extended forecast next.